section, that is topic is branching. So coming to the branching, so in this branching, so we're having a branch of instructions. Coming to the branching, so in this branching we are having some instructions, so we have to follow these instructions to transfer a program. And in order to control a program or transfer a program, we have to from one straight line sequence to another straight line sequence. So we have to send in one straight line sequence to another straight line sequence. We have to follow some branch instructions. So what is mean by branching? So we have to use a branch instruction in order to transfer a program control from one straight line sequence to another straight line sequence of instructions. So in this I having the diagram, a small example of this branching. So in this program we are using some operations, that is modulus a minus b. So for this modulus a minus b, in this program we have to check whether a greater than 1 or b greater than a, or accordingly we can have to perform operations, that is a minus b or b minus a. So this is the branching instructions we have to follow to transfer the data or a program in order to control that from a sequence straight line sequence or one straight line sequence to another straight line sequence. So that is called the branching. So in this we are providing the task of adding a list of n numbers. The program then a program is there. So this is the diagram. So this is the example I am having. In this example I will explain how this branching will be work. And instead of using a long list of added instructions, it is possible to place a single and instructions in a program loop. So the loop of a straight line sequence of instruction executed many times as needed. It starts at location loop and ends the instruction branch greater than 0. So we have to follow the branch instructions in order to transfer the program from one straight line sequence to another straight line sequence. That should be executed in many times. The program can be executed in many times. So by using the branching instructions. So that is it starts at location loop and ends the instruction branch greater than 0. So this is the program I having. So in this program we having using the instructions, that is move. I'm using moving instruction. So moving number 1 to R0. R0 is R means register. Number 1 is our value. So we have to get the number 1 value into the R0. Register 0 lo R number 1 అనేది స్టోర్ అవుతుంది. ఓకేనా, మూవ్ చేస్తాం. సో మనం ఏం చేస్తున్నాము, రిజిస్టర్ 0లో నంబర్ 1 అనే వాల్యూ అనేది మూవ్ చేస్తున్నాం. సో నెక్స్ట్ ఇన్స్ట్రక్షన్ ఏంటి, మూవ్ n to నెంబర్ 2 R1. సో R1 రిజిస్టర్లో which value I am moving, number 2 value is getting in that R1. So now I am doing the comparison between R0 and R1. R0 కి R1 కి కంపారిజన్ చేస్తున్నాను. సో కంపారిజన్ ఎలా రష్ చేస్తారు, n మైనస్ నెంబర్ 1 మైనస్ నెంబర్ 2 ఇలా మనం కంపారిజన్ చేస్తాం. సో నెంబర్ 1 అండ్ నెంబర్ 2 అనేది ఏదో ఒక వాల్యూ తీసుకుంటాం. ఓకేనా, ఆ వాల్యూ అనేది తీసుకున్నప్పుడు ఆ రెండింటికి కంపారిజన్ చేస్తాం. సో ఐబి నెక్స్ట్ అవి ఇన్స్ట్రక్షన్ బ్రాంచ్. ఓకేనా, సో నెక్స్ట్ ఏంటి, ఇఫ్ నెంబర్ 1 గ్రేటర్ దాన్ నెంబర్ 2, నెంబర్ 1 అనేది గ్రేటర్ దాన్ నెంబర్ 2 అయితే జంప్ టు ద అనదర్ ప్రోగ్రామ్ సీక్వెన్స్. ఇట్ విల్ బి నెంబర్ 1 అనేది greater than number 2 if it jumps to the another program sequence. Okay, so we have to do the subtraction now. So R0 R1 ki subtraction చేస్తున్నాను. So number 1 minus number 2. So whenever we are doing the subtraction, the value will be stored in the number 1. So move R2 R1. Now I'm moving that R1 value is moving into the R2. Okay na, so whatever the results we are having, that result is stored in the R2. So store the result in R2. So R1 value అనేది దేంట్లో మూవ్ చేస్తున్న R2 లో మూవ్ చేస్తున్న రిజల్ట్ అనేది R2 లో ఉంటుంది. So on this like the instructions will be followed in the branching. Next subtraction R1 R0. So next number 2 I am doing n2 minus n1. So this is the a minus b and b minus a. This is the subtraction, two types of subtractions. Okay, so now I am moving the R0 value into the R2. So this is one branching instructions. This is a small example of the branching. So this is the program, this is the code which is moving in a straight line, one straight line sequence to another straight line sequence. So in the above program we have used the JB next instructions to transfer the program control to the instruction subtraction R1 to R0 If number 1 is less than number 2, then we have decided the branch, the program control. After checking the condition, the sequence of instruction loops have 4 sections. Four sections of instructions ఉన్నాయి. Initialization section, processing section, loop control section, result section. ఫస్ట్ ఇనిషియలైజ్ చేస్తాము. ఐ మీన్ వాల్యూ అనేది రిజిస్టర్లో ఇనిషియలైజ్ చేస్తాం. అంటే ఫర్ ఎగ్జాంపుల్ రిజిస్టర్ R0 R1 ఉంది, అందులో వాల్యూ అనేది నెంబర్ 1 నెంబర్ 2 వాల్యూస్ అనేది ఇనిషియలైజ్ చేస్తాం. ఇనిషియలైజ్ చేసిన తర్వాత ప్రాసెసింగ్ అనేది జరుగుతుంది. ప్రాసెసింగ్ సెక్షన్లో ఏం చేస్తాము మనము, processing. So this is the flow diagram of this sequencing branching ma. So this is the flow diagram. So this initialization section, processing section, loop control section, result section, these are all the we have seen in this program. This is the small code. In this code we are doing these 4 sections. So how see, first initialize start చేస్తాము. స్టార్ట్ చేసిన తర్వాత మన యొక్క ప్రోగ్రామ్లో మనం వాల్యూస్ని ఇనిషియలైజ్ చేస్తాం. ఇనిషియలైజ్ అంటే నెంబర్ 1 నెంబర్ 2 అన్నాం. సో ఆ వాల్యూస్ని ఇనిషియలైజ్ చేస్తాం. ఇక్కడ ఇనిషియలైజ్ చేసిన తర్వాత ప్రాసెసింగ్ అనేది ప్రాసెసింగ్ సెక్షన్కి వెళ్తుంది. ప్రాసెసింగ్ సెక్షన్లో ఏం జరుగుతుంది, సో గ్రేటర్ దానా నెంబర్ 1 అనేది గ్రేటర్ దానా లెస్ దానా, లేదా నెంబర్ 1కి నెంబర్ 2కి సబ్ట్రాక్షన్ జరగడము. సో ఈ ప్రాసెసింగ్ అంతా అనేది ఈ సెక్షన్లో జరుగుతుంది. ఓకేనా. ఆఫ్టర్ లూప్ కంట్రోల్ సెక్షన్. లూప్ కంట్రోల్ సెక్షన్ ఏంటి, ఒకవేళ వాల్యూ అనేది లూపింగ్ అనేది ఎందుకు యూజ్ చేస్తామో, మనం ఒక కండిషన్ అనేది పెట్టుకుంటాం. ఆ కండిషన్కి అది సాటిస్ఫై అయితే స్టాప్ అయిపోయి రిజల్ట్ అనేది స్టోర్ అయిపోతుంది. ఆ కండిషన్కి స్టాప్ కాకపోతే మళ్ళీ ఆ లూపింగ్ అనేది ఇప్పుడు మన అనుకున్న కండిషన్కి అది రీచ్ అవ్వలేదు, సో మన కండిషన్కి అది సూటబుల్ కాలేదు, మళ్ళీ లూప్ అనేది మళ్ళీ ఫస్ట్ నుంచి మళ్ళీ ప్రాసెస్ ఇనిషియలైజేషన్, మళ్ళీ ప్రాసెసింగ్ సెక్షన్, లూప్ కంట్రోల్, ఇలా ఎంతసేపు అయితే అంతసేపు, అంటే ఎప్పుడు దాకా అయితే మన రిజల్ట్ అనేది సాటిస్ఫై అవుతుందో సో అంత దాకా మనం రిపిటేషన్ అనేది ఎనీ టైమ్స్ బ్రాంచింగ్ ఇన్స్ట్రక్షన్లో మెనీ టైమ్స్ రిపిటేషన్స్ అనేది జరుగుతుంది. మెనీ టైమ్స్ ఇన్స్ట్రక్షన్ అనేది ఎగ్జిక్యూషన్ జరుగుతుంది. సో ఎప్పుడు దాకా అంటే ఇట్ విల్ బి రీచ్ అవర్ expectations. Okay na, if it is our expectation, then it will be result will be stored and processing will be stopped here. So this is the working of the branching instructions. Okay na, branching is this is the flow chart. Next another flow chart of the branching ma. So in this we are having start initializing this section, and we are adding some number 1 and number 2 values in this initialization section, and after initializing the values in this the loop control section will be occurred here. In this loop control we are checking that whatever the value we have taken, that is equal or not. If it is not equal, if it is not reached to our assumption, so it will be looping processing will be start from the starting. Okay na, it will be go to the processing section and it will be go from the faster, and it passes if it is satisfied it will be S, it will be go to the result section and ended. If the satisfaction is not if the user is not satisfied and what he had taken the limited branching limits, that is not reached, then it will be go to the next processing section and it will be transferred to the again it will be processing will be again start from the loop control section. So this up to the result section, up to our expectation of result, up to that the repetition will be occurred. So this is the another flow diagram of the flow chart of the branching. Next, coming to the addressing modes. What is the addressing modes? Okay, so in this program, so once again I'm just to your clarification, I'm repeating. So in this above program we are using the the conditional branch instructions are used for program looping. The conditional branch section instructions are used the program looping. In looping, the program is instructed to execute the certain set of instructions repeatedly to execute a particular task number of times. For example, we had 10 numbers stored in the consecutive memory locations. We have to perform the additions. We have to perform the addition 10 times. We have to perform the addition 10 times. The program loop is the basic structure. The program loop is the basic structure. What is that? The program loop is the basic structure which forces the processors to repeat a sequence of instructions. Loops have 4 sections. That is initialization section, processing section, loop control section, and result section. These are the 4 sections we are having in the flow chart. So loop counters the counting how many times loops executed. So address registered, in this we are having the address registers for indexing, which give the pointers, memory locations and other variables. Okay, so in this actual data manipulation occurs in processor sections. So this is the section which does the work. So in this loop control, in the loop control section, we are going to update the counters, indices, pointers for the next iteration. Okay, so this is the explanation of this diagram. And next coming to the flow addressing modes. Okay, next coming to the addressing modes. So what is mean by addressing modes? So an addressing modes is the another method of specifying an operand. So in these addressing modes, we are having different types of operands, and the operation fields of an instruction specifies the operations to perform. So these operations must be executed on some data stored in the computer registers. So we having different types of addressing modes here. The first one is implied addressing modes. Second one is immediate operand addressing modes. Third one is registered operand addressing modes. Fourth one is registered indirect mode. Fifth one is auto increment and auto decrement. Sixth one is direct addressing modes. Next, seventh one is indirect addressing mode. Eighth one is relative addressing mode. Ninth one is indexed addressing mode. 10th one is base registered addressing mode. So these are the 10 different specific addressing modes are available here. So we will explain every addressing modes now. So before going to explain these types of addressing modes, first of all, just I am going to recollecting that addressing, what is mean by addressing modes. Addressing modes will be providing the operands. What will be provide my operand? It will specify that the addressing modes will be a method of specifying an operand. The operation field of an instruction specifies the operations to be performed. These operations may be executed on some data stored in the computer registers. So these are the different addressing modes we are having. Coming to the first one, that is implied addressing modes. So in this addressing modes, the operands are specified implicitly in the definition of the instructions. So in this we are having small example. So in this instructions, complement accumulator. So the instruction complement accumulator is an implied mode instruction because the operand in the accumulator register is implied in definition of instructions. So I have a small example here. So in this AC accumulator is a, in shortcut we will retain as a AC. So this is the processor. So in this mode, the operands are specified hidden in the instructions. So the instruction operations accumulator is an implied mode instruction because the operand in the accumulator register is implied in the definition of the instructions. So all the register reference instructions that uses an accumulator are implied mode instructions. So zero address instructions are also implied mode instructions. So this is called the implied addressing mode. Second one is immediate addressing mode. What is mean by immediate addressing mode? So this is the example we are having opcode and operand value. So in this mode, operand is specified in the instruction is in itself. So in other words, the no immediate mode instruction has an operand field, then address the field. The operand field contains the actual operand to be used in conjunction with the operation specified in the instruction. This is the example. In this we are having the opcode and operand value. Okay, opcode and operand value. In the operand value, I am storing the value 5. Okay, so in this value, the immediate operand mode normally represents the constant data. The immediate operand, immediate mode will be specifies normally and represents normally a constant data. So that is called the immediate mode. Next, third one is a registered mode. So what is the use of registered mode? In this mode, the operands are in the registers. In this mode, the operands are in the registers. So this is the example we are having. So in this example we are seeing here. So in the IR means the here I am having the IR here. So in this instruction register, I am having the operand, opcode and register operand. So the register operand is stored in the registers. So what I said in this register mode, in this mode, the operands are in whatever the operands in the register operand, whatever the operands we are having, that is operands are is registered in the registered that reside within a CPU, registered in the reside in the within the CPU. Okay, so the whatever the values are available in the register operand, that will be stored in the registers. This is the register bank. So the register we are having the R0 to Rn-1. Okay, so in these registers we are going to store the operand register values. So this is called the registered mode. Okay, so in this register is selected from the register field in instructions. The k bit field can specify any one of 2 power k registers, any one of 2 power k registers. So this is called the registered mode. Next one, fourth one, that is registered indirect mode. So what is the use of registered indirect mode? In this mode, whatever the instruction we are specifying, a register in the CPU whose content give the address in the CPU. Okay, so in this mode we having the instructions, the instruction that specifies the registers in the CPU whose content in the address in the CPU. So where the contents give the address. So if you see the diagram, we can understand very easily, ma. So in this this is the opcode and register bank. In this register bank, whatever the values we have specifying, that values is stored in the registers R0 to Ri. This in this Ri we are having the address of the operand, Okay, so this is the Ri, and if you see the explanation in this mode we having the instructions specifies a registers in CPU whose content gives to the address in the CPU, whose content gives the address of the operand in the memory. Okay, so the CPU whose content gives the address in the CPU, whose content gives the address in the operand data in the memory. Okay, so in other words we can say selected register contains the address of the operand rather than the operand itself. Okay, so this is the explanation of this diagram, and in this it needs to one memory access and another one register access to get the operand data. The advantages of this register indirect mode instruction is that the address field of the instruction uses fewer bits to select a register than would have been required to specify a memory address directly. Okay, so this is called the registered indirect mode. So in this we having the opcode, in this we having the registered bank. In the register bank, whatever the values we are having, so register bank in the previous one, the register mode, this is the register mode. In this we are having the register operand. Okay, so this is the register bank. Okay, so register bank means this is the R0, R1, R-1, this is the register bank. So now in this if you see this diagram, opcode we are having and register bank. So in this register bank we have whatever the values we have stored from the registered operand. Register operand values will be available in the register bank. So the register bank value stored in the address of the operand. Okay, na? Address of the operand in the CPU, and that will be stored in the operand data called memory. So okay, this is the registered indirect mode. Okay, next coming to the auto increment and auto decrement. So this is similar to the register indirect mode, except that the register is incremented or decremented after or before its value is used to access the memory. So when the address is stored in the register, when the address is stored in the register, it refers to a table of the data in the memory. So it is necessary to increment and decrement the register after every access to the table. So this is the diagram. So in this diagram we are having the opcode. Okay, na? Opcode, operand address. Okay, na? So what we have said that, so it is similar to the register indirect mode. So except that the register will be the registers in the registers we are going to increment and decrement after and before its value is used to access the memory. So memory access, before accessing the memory we have to do the increment and decrement of the register values. When the address stored in the register, it defines the table of data in the memory, and it is necessary to increment or decrement the register after every access to the table. So this is called the auto increment and decrement. So next coming to the direct addressing mode. So what is mean by direct addressing mode? In this mode, the effective address is equal to the address given directly by the address field of the instructions. Okay, so the operand resides in memory and its address is given to directly to the address. So operand So operand, whatever the values we are operand, the operand resides in the memory. Operands will be stored in the memory, and its address is given by the its address is given directly to the address field of the instructions. So in this example, so I am taking the 0, that add 0 add to the 1000. The content of the 1000 memory locations is added to the accumulator, and result is stored in the accumulator. So this is the direct address mode. Next, coming to indirect addressing mode. So what is mean by indirect addressing mode? In this mode, the address field of the instruction gives the address, the address field. This is the address field. In this diagram, we are having the address field. In this address field of the instruction gives the address where the effective address of ones is stored in the memory. Okay, so ones is stored in the memory. We have to control and fetch the instructions from the memory, and uses its address to access the memory, again to read the effective address. So we have to fetch the instructions from the memory and uses the address to access the memory, again to read the effective addresses. So this is the formula we are having. Effective addresses is equal to address part of instruction plus content of CPU register. So this is in this diagram we are having the opcode and opcode address. So in this opcode address, value is given to the address is given to the memory, that is operand data. So that is stored in the memory. So effective address is equal to address part of the instruction plus content of CPU registers. So this is the indirect mode. So next, coming to the 8th one, that is relative addressing mode. So what is mean by relative addressing mode? So in the relative addressing mode, in this mode, the instruction contains a relative address which is actually a signed number, that is 2's complement form. So what is mean by relative address mode, ma? So in this addressing mode, whatever the instructions we are having, that contains the relative address which is actually a signed number, that is indicated in the 2's complement form, which can be either a positive or a negative. So the effective address is equal to PC plus 1 plus address specified in the instructions. Okay, so the effective address is a PC plus 1 plus address specified in the instructions. So PC is nothing but program counter. So program counter plus 1. So plus address specified in the instructions. So and this is the diagram we are having. In this we are having opcode and operand date address, operand addresses, and memory. So in the memory we have operand data. So whatever the operand address in this, whatever the value we are having, that value is given to the operand data. So for whatever the data we are taking in this relative addressing mode, we are adding the one value for the program counter. For this opcode operand address, whatever the program or code we are available for that data, I am going to add the plus 1. I mean program counter plus 1. Okay, data plus 1. So after giving that value, and that will be stored in the memory, that is operand data. So this is called relative addressing mode. Okay, so in this this type of addressing mode is commonly used dealing with the branch type instructions, where the branch address is located in the area where the instruction code is also stored. So this is called the relative addressing mode. Next, coming to the 8th to 9th one, indexed addressing mode. So what is mean by indexed addressing mode? In this mode, the content of index. In this mode, the content of index register. In this mode, the content of indexed register is added to the address part of the instructions. So this is the diagram. In this opcode we are having opcode and operand address. So indexed register is added to the address part of the instruction to obtain the effective address. So effective address is nothing but instruction register plus address specified in the instructions. So this is the formula. Effective address is equal to IR plus address specified in the instructions. So in this index stored in the index register is actually difference between starting address and effective address. If address field is not specified within the index type, the instructions it starts operating in the register indirect mode. So this is called the index addressing mode. So this is the diagram. So in this diagram we are having the opcode and operand address, and we are using the some plus addition expression here, one operation. So in this operation we are giving the data. So So for this data, after processing this data here, if this data is given to the memory, and in the memory it will be stored. Okay, so operand data. So index addressing mode. Next, coming to the 10th one, base register addressing mode. So what is mean by base register addressing mode? So in this mode, the content of base register is added to the address port of the instructions to obtain the effective address. So this is similar to the indexed addressing mode, except that the register called base register and instead of indexed register. So in this field of instructions, we are specifying the number of modes, that is direct address mode, indirect address mode. So number of modes we are having, like whatever we have discussed now. In this also we will discuss that direct addressing mode, immediate mode, indirect mode, relation mode, indexed mode, registered indirect mode, and these are the different things we are having in the base register addressing mode. So what is first one? In this first one we are having direct addressing mode. So it is in this effective address is the part of the instructions. So effective address part of the instruction is 500 and operand to be located into the accumulator, that is AC, is 800. Okay, so this is in this direct addressing mode I am having a small diagram. So this is the diagram I am having. So this is the main diagram of the base register addressing mode. So I having these some values here. So we have different register values here. So load AC. Okay. So now I am going to explain this. So this is in this mode the content of base register. The content of base register is added to the address port of the instruction to obtain the effective address. So in this we having different modes. That is first one, direct address mode. So what I said, the effective address. So the effective address of the address port of the instruction 500. So this is the my address 500. So I'm loading the accumulator mode here in the 200 at 201 201 address value is 500. Okay, and next instruction is I am following. So in this address port of this instruction, I am taking 500 and the operand to be located into AC, and operand is, so whatever the operand I am using that is located into the accumulator AC is 800. So what is our last value here? 800. Okay, accumulator mode is 800, and that is called the direct address mode. Okay, next coming to immediate mode. What is mean by immediate mode? So in the second word of the instruction, so every this is 1 byte. This is the storage space. This is the memory. In this memory we are having the this is 1 byte. Different number of bytes we are having. So every byte we are storing the words. Okay, na? We are storing the words. So the second word of the instruction is taken as the operand. The second word of instruction is taken as a operand rather than an address. So 500 is loaded into the accumulator. 500 is loaded into the accumulator. That is effective address is 200. So what is effective address here? 200. So we are going to load the accumulator mode. In this accumulator mode, what we are having the we are located some operand here. So we are taking the in the next step we are taking the address port is instruction is taking the 500, and if we talk about the immediate mode, in this immediate mode, in the second word of the instruction is taken as the operand rather than the address. So the 500 is loaded into the accumulator, and that is effective address mode. That is 200. Okay, na? So 200. So next coming to the indirect mode, that is third one. So in this effective address is stored in the memory. So address is stored in the memory of the address 500. Address is stored in the, so the effective address is stored in the memory of the address 500. So the effective address is 800. Actual effective address is how much? 800, and we are storing into the, and the effective address is stored in the memory address is 500. Okay, na? 500, and the effective address of address is 800, and what is operand? 300. So ఇక్కడ 800 ఇచ్చినాము, So this is address, effective address is 800, and in this we are having storing the operand 300. Okay, and here I am taking the 500, and it is stored in the accumulator. Whatever the operations or operands are stored in the accumulator. So this is the address of the accumulator is what, 200. So okay now, so this this is called the indirect mode. Okay, so next coming to relative mode. What is mean by relative mode? Effective address is 500. Mana address enti effective address 500. Okay na, 500 key value enta. Next instruction we are going to add the 202 202 I am adding. Total value how much? 702, and the operand is 325. What is the operand? 325. So 702 తీసుకుంటే ఎంత ఉంది? 325. సో ఈ డయాగ్రామ్ చూస్తే మీకు అర్థమవుతుందా? ఇక్కడ నేను ఏం లోడ్ చేస్తున్నామా, అక్యుములేటర్ మోడ్ అనేది లోడ్ చేస్తున్నాను. 200 దగ్గర అక్యుములేటర్ మోడ్ అనేది లోడ్ చేస్తున్నాను. సో మనం డైరెక్ట్ దీంట్లో డిఫరెంట్ నేమ్స్ తో మనం కాల్ చేస్తాం. డైరెక్ట్ అడ్రస్ మోడ్ అంటే, సో ఇందులో ఎఫెక్టివ్ అడ్రసెస్ పక్కన 200, 201, 22, 202, 399 ఇవన్నీ ఏంటంటే అడ్రసెస్ మా. సో ఓకేనా, ఇన్ దిస్ ఎఫెక్టివ్ అడ్రస్ ఈస్ అడ్రస్ పార్ట్ ఆఫ్ ది ఇన్స్ట్రక్షన్ 500. అడ్రస్ ఈజ్ ఈక్వల్ టు 500 ఉంది. సో అడ్రస్ ఈజ్ ఈక్వల్ టు 500 and instructions 500 and operand is loaded. So we have to use the operand is loaded or located into the accumulator AC and is 800. accumulator AC, this is the 800. okay, దాన్ని ఏమంటారు? డైరెక్ట్ అడ్రసింగ్ మోడ్ అంటాం. సెకండ్ వన్ వచ్చి ఇమీడియట్ మోడ్. సెకండ్ మోడ్ ఏదైతే ఇన్స్ట్రక్షన్ ఉంటుందో ఆ ఇన్స్ట్రక్షన్ ఇస్ టేకెన్ యాజ్ ఏ ఆపరెండ్ రాదర్ దాన్ అడ్రస్ ఈస్ 500 తీసుకున్నాము. సో దేంట్లో లోడ్ చేస్తున్నాము? అక్యుములేటర్లో లోడ్ చేస్తున్నాము. అది దాన్ని ఏమంటారు అంటే ఎఫెక్టివ్ అడ్రస్ ఇస్ 200 తీసుకుంటున్నాం. సో ఇండైరెక్ట్ మోడ్లో ఏంటి? ఎఫెక్టివ్ అడ్రస్ స్టోర్డ్ ఇన్ ద మెమోరీ ఆఫ్ ది అడ్రస్, దట్ ఈస్ 500. సో ఎఫెక్టివ్ అడ్రస్, దాని యొక్క ఎఫెక్టివ్ అడ్రస్ ఏంటి? 800. దాంట్లో వాల్యూ ఎంత ఉంది మనకి? ఆపరెండ్ వాట్ ఈస్ ద ఆపరెండ్? 300. ఓకే, సో వాట్ ఈస్ ద రిలేటివ్ మోడ్? వాట్ ఎవర్ ద రిలేటివ్ మోడ్, అవర్ యాక్చువల్ ఎఫెక్టివ్ అడ్రస్ ఏంటి? 500. సో 500కి నెక్స్ట్ స్టెప్కి వెళ్ళాలి. నెక్స్ట్ స్టెప్లో ఎంత ఉంది వాల్యూ? 200 ఉంది. సో 500 ప్లస్ 2 702. 702లో నాకు ఎంత వాల్యూ వచ్చింది? ఆపరెండ్. దిస్ ఇస్ ద అడ్రస్. 702 అనేది అడ్రస్. దాంట్లో ఆ వాల్యూ ఎంత ఉంది నాకు? 325. ఓకేనా, 325 వస్తుంది. సో దిస్ ఈజ్ ప్రోగ్రామ్ కౌంటర్. సో దిస్ ఈజ్ ద ప్రోగ్రామ్ కౌంటర్ ఆఫ్టర్ ఫెచ్చింగ్. ఓకే, సో వీఆర్ గెటింగ్ 325. దట్ ఈస్ కాల్డ్ ద రిలేటివ్ మోడ్. నెక్స్ట్ కమింగ్ టు ఇండెక్స్డ్ మోడ్. సో వాట్ ఈస్ మీన్ బై ఇండెక్స్డ్ మోడ్? XR ప్లస్ 500. సో XR ప్లస్ 500 ఎంత? XR ఎంత మనకి? 100. ఓకేనా, 100. సో XR ఎంత తీసుకున్నాం? ఇక్కడ చూసుకుంటే పక్కన XR ఉంది. ఓకేనా, XR ఎంత? 500. 100 ప్లస్ 500 మనకి యాక్చువల్ ఎఫెక్టివ్ అడ్రస్ ఎంత? 500. అవి రెండింటిని కలిపితే ఎంత? సో 500. XR ప్లస్ 500. XR అంటే 100 ప్లస్ 500 ఈజ్ ఈక్వల్ టు 100 ప్లస్ 500 తీసుకో. అండ్ ఆపరెండ్ ఎంత? 900. 600 అన్నాం కదా. XR అంటే 100 ప్లస్ affective address enta 500. We have to add for that two values, that is 600. At the 600 what will be the operand value? Okay, what will the operand value? 900. Okay na, so that is the operand value 900. This is called the indexed mode. Next, registered mode. What is mean by registered mode? So what is mean by registered mode? In this the operand is in R1. So operand were R1. So R1 we are having R1 and 400 is loaded into the accumulator. This is called the registered mode. So we are going to register the value in the accumulator. Okay. Register indirect mode. What is mean by register indirect mode? So the effective address is, what is the effective address actual now? No, register mode lo enti operand value R1 తీసుకుంటున్నాను. సో దాంట్లో వాల్యూ ఎంత ఉంది? 400. అది దేంట్లో లోడ్ చేస్తున్నాను? అక్యుములేటర్ ఏసీలో స్టోర్ చేస్తున్నాను, ఏసీ మోడ్లో. సో నౌ వాట్ ఈస్ ద రిజిస్టర్డ్ ఇండైరెక్ట్ మోడ్? సో నౌ అవర్ యాక్చువల్ ఎఫెక్టివ్ అడ్రస్ ఇస్ 400. దట్ ఈస్ ఈక్వల్ టు కంటెంట్ ఆఫ్ R1. సో వాట్ ఎవర్ ద కంటెంట్, వాట్ ద కంటెంట్ ఈస్ హియర్ we are having R1 is equal to 400. So what is the equal? That is equal to the content of R1, and operand is loaded into the AC is 700. So this is the registered indirect mode. Okay na, so this is the explanation of this numerical example, and I have small diagram here. So this is the operand, opcode, operand address, and we are using some operation here and base, and this is stored into the operand data. Okay, na? So this is the main example diagram of this base instructions. Okay, na? Now, base addressing mode. Next, coming to auto increment mode. In this we are having auto increment mode. So the 2 word instructions, so if you see this one, so again, so the 2 word instructions of address 200 and 201 is the load to accumulator instruction with an address field equal to 500. Okay, the first word of the instruction, specifies the operation code and made, and the second word specifies the address port. So PC is a program counter, has a value 200. For fetching these instructions, AC receives the operand after instruction is executed. So in this we are having the auto increment mode. It is the same as register indirect mode, except that R1 is incremented to R401. Okay, so the auto incremented mode decrements the R1 to 4399 to the execution of the instruction, and the operand loaded into the AC is now 450. Okay, so this is the auto increment and auto decrement mode. Next, coming to basic input and output operations. So what is mean by basic input and output operations? So a task, so whatever the task that reads in character input from keyboard and produces character output on a display screen. Okay, so whatever the data are taken, that the data are transferred between the memory of a computer and outside of the world, and whatever outside of the world. In this we are having the input and output operations. In this we are having the input and output operations. Input and output operations are essentially, and the way they are performed can have a significant effect and performance of the computer. So in this we are having the task. So whatever the data we are having, the data is transformed between the memory and the memory of a computer and the outside of the world. So in this input and output operations, the way that performed and significant effect on the performance of a computer. So whatever the task we are having, the task is reads in character input from a keyboard and produces the character output on a display screen. A simple way of performing such input and output task is to a method known as program controlled input output. So already you know this is the basic input and output operations. So if you take our computer, we will take the we will use the keyboard. Through the keyboard I am giving the input information or any operations in the further system, that is stored memory of the computer, and it will be given the outside of the world, and whatever the operations we are performing, that will be performed in the performance of a computer. And we have taking the task. That task is read in the character through the input from the keyboard and produces the character output on a display screen. So a simple way of performing such input and output task is using the program control, that is input and output. So the rate of data transfer from a keyboard to a computer is limited by typing speed of the user. So depending on the user typing speed, the system will be transfer the data rate. Data rate will be calculated depending upon the speed of the user, typing speed of the user, which is unlikely to exceed a few characters per second. The rate of output transfer computer and display in the much higher. So it is determined by the rate of the characters to be transmitted over the link between the computer and the display screen. So whatever typical several thousand characters per second. So this is still much slower than the speed of the processor that can execute many millions of instructions per second. The difference is speed between the processor and the output devices creates the need for mechanism for synchronize the transfer of data between them. So what is mean by this? So whatever the data we are taking from the input, that operation is performed on the screen, and it will be release the data on the display of the release the output on the display of the system. So in this we are Yeah. So whatever the we have to we have to measure the performance of the computer. So depending on the user typing speed, we are going to